Hello students, welcome back. This is lesson 4, Simple Machines. Let's get started. We're going to talk about simple machines as devices that transfer energy. Screws, ramps, hammers, hockey sticks. Yes, I like that one. We'll talk about simple machines as force multipliers. We're going to describe all simple machines as having an input force, an output force, and a fulcrum. And we're going to explain the functioning of common household machines, such as crowbars, scissors. All right, moving on. So, how do machines work? Well, basically, machines work by 1, changing the size of the force, and 2, changing the direction in which the force is needed. So we'll take a look at some examples here. So first of all, let's talk about the 6 simple machines. There's the inclined plane, there's the screw, and the wedge, the lever, the pulley, and the wheel and axle. So let's talk about the inclined plane. It has a sloping surface. It makes work easier by increasing the distance, which decreases the force. I'll show you that in a sec. And the lower the slope of the ramp, the easier the work. So let's take a look at some pictures. So first of all, we have a sloping surface. So you can see that we got some slope here. Now, it makes work easier because it increases the distance. What we're trying to do is lift this piano from here up to here. Now, the distance it has to go is like that. But if we stretch it over this longer distance here, it's a lot easier. Okay? And to get that block to the top of the pyramid, they made these slaves push them up this long ramp. And that made it a lot easier to get the rock up to the top. I still question some of their labor practices back in the day, but anyway. Man, I look at this piano. Once I was having some people help me move, and they had taken my piano to the other house. When I drove up, they're rolling the piano down the ramp, and I was not too happy about that. I don't think it was damaged, but man, they just let it roll. They didn't try to hold on. The ramp was not my friend at that moment. Anyway, okay, moving on. The next simple machine is the screw. The screw is an inclined plane. It's actually an inclined plane, what we just looked at, wrapped around a cylinder. The examples are drill bits, jar lids, nuts, bolts. The threads increase the distance, which decreases the force. So, like I said, the screw is an inclined plane wrapped around a cylinder. So, if you just look at the threads here, these threads are really just a hill. But the hill isn't going up like this. We're just wrapping the hill around this bar. So, when you push a screw into wood or when you twist a screw, it's the same as having something climb up a ramp. So, and that decreases the work. So examples are drill bits. A jar lid is the same kind of thing. When you put a nut and bolt together, same kind of thing. And again, the threads increase the distance, which decreases the force. If this screw here did not have the ramp around it, if you tried to put it in to a piece of wood by turning it, it just wouldn't go in. So the ramp actually makes it easier. Okay, next we have a wedge. A wedge is really 2 inclined planes joined back to back. Wedges are used to split or hold objects in place. Examples are axe heads, knives, chisels. The thinner the wedge, the less force is needed, and a small surface area means greater pressure. So, there's a wedge. You can see that a wedge is really just an inclined plane, and then another one put on its back. So, they're really just 2 inclined planes. We know they're used to split like an axe head. Like the thinner it is, the less force is needed to jam it into something. And right here, there's a small surface area that's actually striking the object, and that means a lot greater pressure. Okay, next we have the lever. So a wheelbarrow is a type of lever. Lever is a solid bar that rotates, turns, or pivots around a fixed point. The fixed point is called a fulcrum. It can multiply the input force and change direction. It depends on the position of the fulcrum. And there are 3 classes of levers: first, second, and third class. So let's look at some examples. Okay, there's a first class lever. So the thing to notice here is the fulcrum is positioned somewhere in the middle. And then you have a load, and a load. And then you have the force that you apply. So the fulcrum is between the load and the force. So there's my force, there's my force, and there's my force. So force, and then fulcrum, and then load. Force, fulcrum, load. Okay, let's look at the next example. Okay, second class lever. Looks like that. So you can see the difference here. Now the fulcrum is on the end. The fulcrum is on the end. And the load is the thing that's in the middle. The load. And then the force is on the end. Okay, that's a second class lever. Third class lever. Okay, a third class lever looks like that. So a hammer or some tweezers. Now with a third class lever, the fulcrum is still on the end. Okay. And the fulcrum, maybe I didn't say that. The fulcrum is the pivot point. Like we pivot right here, right? The bar moves off of that point. Anyway, okay, now the difference here is now the load is on the end this time. The load is on the end. The load is on the end, which is different than the second class lever where the load was in the middle. This time the force is in the middle. So my hand is in the middle. My fingers are in the middle, pushing. Okay? All right, so there's your types of levers. Okay, and now we'll go to the pulley. Pulleys are wheels and axles with a groove. The single pulley makes work easier by changing the direction of the force. Pulley needs a rope and a chain or a belt around a groove. So there's an example of a pulley. Okay, next, the pulley. The pulley is just a wheel and axle with a groove around the outside. Makes work easier by changing direction, and you gotta have a rope or a chain or a belt or something that goes in a groove. All right, so there's some pictures of a pulley. So first of all, it's a wheel and an axle. So you can see we have a wheel, axle. I'm probably going out of order because the next one actually talks about wheel and axles, but anyway, we change the direction of the force. So we pull this way, the load goes that way. We need to have a rope or a chain, so you can see there's a groove that this fits into. Okay. All right, good. That's the pulley. And now we got the wheel and axle. So an axle is stuck rigidly to a large wheel. The axle is like a fulcrum. And when the axle turns the wheel, there's a greater distance and therefore less force that needs to be applied to the axle. All right, so let's analyze this a little bit more. So the axle is stuck rigidly to a large wheel. So when we turn this crank, we create this circle, which is the wheel. And then this axle is rigidly stuck to this wheel. Okay. The axle acts like a fulcrum, so there's a pivot point. And when the axle turns the wheel, there's a greater distance and therefore less force. So if I was to just grab my hand on right there, let's say this was gone, And if I was to just try to twist that with just my hand, it would be a lot harder than having this crank, which creates this big circle. If I was just grabbing the axle, I'd be turning a little circle. This is a much bigger circle, which decreases the force on the load, which is the bucket. Okay, good. Clean that up. So I believe that is everything. Oh, yeah, there's some videos. Check out Bill Nye's Simple Machines. It's actually really good. And then in class, last semester, we built catapults, but we're not in class now, so I can maybe make this bonus work of some kind. If you build a catapult, send me a video of it working and put yourself in it so I can tell it's you, and maybe I can give you some bonus marks. Okay, go ahead and do the lesson. Take your notes and do the assignment. It's a pretty easy assignment. Okay, we'll see you next time. Thanks.